Hello friends, now we will discuss about a very important concept of thermodynamics, that is entropy. Entropy is denoted by capital S. Now what is entropy? Entropy is a thermodynamic function which measures the randomness of a system. Actually, its change, that is delta S, is equal to reversible heat change divided by absolute temperature. So, entropy is a thermodynamic function which measures the randomness of a system, and change of entropy, that is delta S, is measured by the ratio of reversible heat change and absolute temperature of the system. Now, what is the utility to define entropy, or what is the importance of entropy? Actually, entropy of the universe determines the spontaneity of a reaction. Actually, there is a direct relation between spontaneity and equilibrium state of a system with entropy. Let us consider this spontaneity. Spontaneous process. For any spontaneous process, delta S universe is greater than equal to 0. Now what is delta S universe? Delta S universe is delta S system plus delta S surroundings. It is greater than 0. Now we will discuss about the characteristics of entropy. Characteristics of entropy. Number 1, like internal energy or enthalpy, entropy is an extensive property of the system. Extensive property. That means entropy depends on mass. Number 2, change in entropy, that is ds, is a state function. Now, the second law of thermodynamics can be stated in terms of entropy change. Second law of thermodynamics can be stated in terms of entropy change. What is it? It states that the entropy change of the universe tends to maximize. The entropy change of the universe gradually increases and it tends to maximize. This is second law of thermodynamics. A very important concept of thermodynamics is entropy. And in terms of second law, we can state that for the universe, the entropy gradually increases and it tends to maximize. We have discussed about spontaneity and entropy change of the system. Now we correlate entropy change with equilibrium condition. When the system is in equilibrium, delta S universe is equal to 0. Now let us consider a problem. Say the problem is that entropy change of system is 20 kilojoule mole inverse Kelvin inverse. Predict whether the process is spontaneous or not. Actually, if this is the question, we can't answer it because here the entropy change of the system is given. Actually, we know that entropy change of the universe must be greater than 0 for spontaneous process. Now, in this case, the entropy change of the system is given and it is positive, but we cannot say the process is spontaneous or not, because if delta S surrounding is equal to minus 30 kilojoule mole inverse, mind it, Kelvin inverse. The unit of entropy change is kilojoule mole inverse Kelvin inverse in SI system. If the entropy change of the surrounding is minus 30 kilojoule, then the entropy change of the universe is 20 minus 30, that is equal to minus 10 kilojoule mole inverse Kelvin inverse. So, if entropy change of the system is positive, but entropy change of the surrounding is negative, and the magnitude of entropy change of surrounding is greater than the system, then the process is non-spontaneous. Or if the entropy change of the surrounding is also positive, then we can definitely say the process is spontaneous. So this is all about entropy and entropy change. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.